Alright guys, so you know I'm not going to be here today, and you know that you have to get this stuff done. So last time we started talking about solving unit circle equations that were not a part of the unit circle. So we said, hey, we have to get our calculator, so I'm going to come over here, and I'm going to make sure we remember a few things about our calculator. Remember, number one, it always has to be in radian mode up here. So if you don't know how to put it in radian mode, remember the mode button. Then we scooch you down here, we make sure the black box is on radian, we press enter, and then we quit. Not so bad. Now, when we're using my calculator, we're going to get big, long, ooky decimals. We always want to use 3 decimal places. Okay? Now, before we do that, I want to go ahead and I want to remind you what it looks like to solve a trig equation and all the fancy words that we need. So, I'm going to go ahead and I'm just going to draw a cute little right here to split apart this that we did last time and to show you our new stuff for today. So the very first thing we want to do is I want to give you an equation like 1 plus cosine 3x equals 0. So if I look at an equation like this, we got a couple things going on. Number one, we know we want to get cosine all by itself. So we have to get rid of that one. First thing I'm going to do is I'm going to subtract 1 on both sides. Subtract 1 here, subtract 1 here. That's a big old fat 0. So now I have cosine of 3x equals -1. Now I want you to notice, this has a 3x in it, and we haven't really talked about the 3x. We've talked about cosine is equal to -1, but not cosine 3x. So what we're going to do here is instead of this 3x, I'm going to change it for just a minute. And I'm going to take my pencil, and instead of 3x, I'm going to write down your favorite math symbol, and I'm going to turn that into a theta. So now I get to ask myself, oh, there's people running in the hall, that's fun. So now I get to ask myself, if cosine of theta is equal to -1, when does that happen? Well, on the unit circle, the only time we have a cosine that's a -1 is when theta equals pi. Okay? Now, if you remember, it's not really a theta, because if I use my fancy schmancy eraser and I get rid of theta, it wasn't theta, it was really 3x. So I'm going to turn this into 3x equals pi. Now I know that this is 3x equals pi. I'm going to get rid of that 3 because this is an old school equation. So I divide by 3, I divide by 3, and I find out that x is equal to pi over 3. Now if I wanted to turn this into the general solutions, right? I would say, hey, for my general solutions, I would take that x equals pi over 3, and I'm going to add 2 pi n, but it's going to be 2 pi n over 3, because if you remember, to get my general solutions, I do my general solutions here before I do the dividing. So right here, I would have said 3x equals pi plus 2 pi n, and then I would have divided by 3 here, divided by 3 here, divided by 3 here. So that gets me up here to this 2 pi 3 over n. Now the other problem is, if I had given you this original problem and told you that I wanted it within the boundary from 0 to 2 pi, well, we know x equals pi over 3 is in the 2 pi boundary because that's part of my unit circle. But because we're changing things up a little bit, what I also need to do is I need to take into account all of the times I could have gone around. And that's where my general solution comes in handy. If I was here and I said I want to go around one more time, that would mean that I would make n equal 1. If I make n equal 1, then I know from my general solution right here that x is equal to pi over 3 plus 2 pi over 3 times 1. Well, 2 pi over 3 times 1 is just 2 pi over 3. So 1 pi over 3 plus 2 pi over 3 is 3 pi over 3. Well, 3 pi over 3 is just pi. Well, that was one time around. What if I wanted one more again? Well, this time I would say that n equals 2. So I would say x equals pi over 3 plus 2 pi over 3 times 2. Well, 2 pi over 3 times 2 is 4 pi over 3, so now I have pi over 3 plus 4 pi over 3. Well, 1 pi over 3 plus 4 pi over 3 is 5 pi over 3. So now I actually have 3 values between 0 and 2 pi where this is true. So for my principal solution, I would get x equals pi over 3. This is my principal value right here. For my general solution, I get pi over 3 plus 2 pi over 3n. For all the solutions between 0 and 2 pi, I would have to list x equals pi over 3, pi, 5 pi over 3, and I could try one more because I know if I go around one more time, but I'm pretty sure that's going to get me out of that 2 pi range. So I don't want to go one more after that. I want to stick with this 5 pi over 3. Okay, so that's one example. Pretty complicated. I'm sorry that we started with one that hard, but let me show you another one that's not quite so bad before we use our calculator. Okay, example number 2. Move this out of the way. We don't want that paper under there. Example number 2 would be something along the lines of no, I don't want that. 4 cosine x equals 2. We'll make it a negative 2. So if I wanted 4 cosine x equals negative 2, if I wanted to solve this, remember, cosine is what I want to get by myself, so I'm going to divide both sides by 4. And when I do that, I get cosine x equals negative 2 over 4. Because that is just an x. I get to use my brain. I don't have to do anything fancy. 2 over 4 is 1/2. So cosine x equals negative 1/2. Nice. When on the unit circle does cosine equal negative 1/2? Well, cosine is 1/2 at my green values, which is my pi over 3 values. Since it's negative, I'm going to be in quadrants 2 and 3. So I'm going to say x equals 2 pi over 3 and x equals 4 pi over 3. This is my exact values. These are my principal values. This is what happens automatically. If I want my general solutions, because I didn't do any weird dividing in here, for my general solutions, all I would have to do is add the 2 pi in. So I would get x equals 2 pi over 3 plus 2 pi n, and I would get x equals 4 pi over 3 plus 2 pi n. Okay, so that one was a little more straightforward. We don't have to worry as much about that one, and that is because right here there is only an x. Remember, when there's not only an x in there, that's when we have the ones that are a little bit harder. That's when that period changes and we have to change everything that's going on. So if we go back and look, I don't know that I have, oh yeah. So we had done this, we added that extra step if we look down here. And we said if there's a b value, we solve it like normal, but then we have to divide. Okay, now let's go with one more. And this is a calculator problem. Okay, so get your calculator handy dandy and let's look at this. So if I gave you a problem, we'll do two. We'll do one with a craziness and one without craziness. So if I just told you sine x equals 1/3. Well, 1/3 is never, ever, 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 ever on the unit circle. So we can't use that. Okay? Second thing I need to look at is I need to look at my information for sine. When I have sine, when I use my calculator, it's going to give me a value in quadrant 1 or in quadrant 4. My job to get the other values is to either take pi minus the principal value or pi plus the principal value, depending on what I get. So I'm going to come over here. Sine x equals 1/3 is never, ever, 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 ever on the unit circle. So I'm going to write this down as x equals inverse sine of 1/3. That's what I get to type in. So I'm going to come right here. I'm going to second sine, I like my fraction, 1/3, close my parentheses, and now I'm going to press enter. When I press enter, I get 0.33983699095. I want 3 decimal places. So that means I get 0.339. That's an 8 after it, so I'm going to write down 0.340. Let me show you. So I get x equals 0.33983699095. Nobody in their right mind wants to write all of that down, so this is what I need right here. 3 decimal places. 0.339, that's an 8. It means rounded up, so that means x equals 0.340. That's my first answer. To get my second answer, this says I am going to take pi, and I'm going to subtract that principal value that I got. I can do that. Okay. So that means my second answer, x equals pi minus 0.340. So I come over here to my handy dandy calculator. We don't want that, that's for sure. And I'm going to say pi, it's right there, minus, remember, I like to steal my answer, so I'm going to use the up arrow and copy paste, and I'm going to press enter. If I look at this and I want 3 decimal places, I get 2.801. It's a 7 after it, so my second answer is going to be 2.802. Okay, that's pretty cool. Last one is going to be one with a little more steps to it, just because that's going to make things weird. Okay, so for my last one, just for fun, we're going to say, hey, watch this. Somebody's using a hammer and nail right now. So if I gave you, let's do a tangent. -10 tangent x equals 27. Well, what would I do here? To get tangent all by itself, I'm going to divide by -10. I'm going to divide by -10. So I get tangent x equals -2.7. Eek. I'm pretty sure that's right. If I divide 27 divided by 10, yeah, I get 2.7. So now, tangent x equals -2.7. I am going to change that to my alternate form. X equals inverse tangent of -2.7. Okay, now I'm going to make a little side note here. I just want to point this out to you because you're super smart. Right here, this -2.7, I'm going to tell you right here, tangent is the only trig function that can be equal to a number greater than 1. When you're talking about sine and cosine, if you tried to put in inverse sine or inverse cosine of something that is bigger than 1, you're going to get an error message. But it actually works for tangent. So when I hit inverse tangent, negative 2.7, there we go, I end up with negative 1.216090675. So that tells me x equals negative 1.216. Problem is, let's look back and see. If I got x equals negative 1.216 for tangent, positive values will give me an answer in quadrant 1. Negative values are going to give me an answer in quadrant 4. I don't want quadrant 4. Quadrant 4 is bad. So I take that principal value and I'm going to add pi. So for this guy right here, I know that I have to take my second value, or this value, and I have to say x equals negative 1.216 plus pi. When I do that, I come up here, I hit enter, plus, and now I'm going to add pi. Now I have 1.9255, so that is x equals 1.926. So now I have two values for tangent. This one is in quadrant 4. This one will be over in quadrant 2. Remember, my x values are always going to be my radian values. And we're just writing these radians as numbers instead of using the pi's. Okay? All right, so you have an assignment. I would like for you to work that assignment. I have an answer key for you in the back of the room that you can check. And I will do my best to get back before the end of class. Hopefully, fingers crossed, we'll see what happens.